Alright, so this video is meant to help you with your homework if you are struggling with these equations where y varies directly as x. So what I've written so far, or typed, is the exact same directions that are in your book, and it says y varies directly as x. Well, all that sentence is saying is that we're dealing with direct variation. And if you remember, direct variation is always of the form y equals kx, where k is a number. It could be a fraction, it could be a decimal, it could be an integer, it doesn't matter. But if you remember, if k is positive, then the graph will have a positive slope, it'll go up. If k is negative, it'll have a negative slope, it'll go down. So when they say write a direct variation equation that relates y and x, all they're saying is find k for this equation and put it into the equation. And then after that, where it says then solve, it's saying use your equation to find a different y value. So if you notice, I actually haven't given you a problem yet. I just wrote down the general directions. But say our problem is y equals 7 when x equals 2. Write the direct variation equation, and then it'll say find y when x equals 5. So I've actually purposefully given you one that will not work out perfectly evenly. We'll get a k value that's not an integer. So the first thing that you want to do is to write the equation y equals kx, because we know it's going to be that general form. Well, they've given you a y value, they've given you an x value. Plug in y equals 7 and x equals 2. So 7 equals k times 2. And you can either write k times 2 like this, or I would like you guys to get in the habit of writing parentheses when you substitute something. It'll help you later on when you have to substitute expressions instead of numbers. So now we have to undo this multiplication, and so to do that we need to divide both sides by 2. The 2's are going to cancel over here, and we get that k equals 7 halves. Now 7 halves is 3.5, but we don't want to write it as 3.5, because if I wrote y equals 3.5x, it looks rather silly. So instead of writing this as 3.5x, we're just going to leave it as y equals 7 halves x. Or, if you prefer decimals, you're welcome to write this as y equals 3.5x. So both of these would be correct for this first part, write a direct variation equation that relates y and x. But then the second part says, then solve. So we're now looking at the second sentence where it says, find y when x is 5. Well, the cool thing is this equation allows us to find any y value for any x value. I could ask you find y when x is 1,000, find y when x is 1,000,000, find y when x is 3.1415, which if you recognize that's kind of the decimal of pi. I could ask you find y when x is 2,300. I could ask you anything. But with this equation, if we know x, we can find y. All we have to do is plug it in. So write your equation y equals 7 halves x, and I'm going to kind of talk through both forms of decimal and fraction. You shouldn't be afraid of using fractions. So here, oops, I didn't plug it in over here. So this would be y equals 7 halves times 5. Now if you remember, this is a fraction, this is a whole number. We need to write this over 1, and so y equals 35 halves. Now at this point, it's okay to write this as a mixed number. This would be 17.5. Over here, if you just multiply this in your calculator, for those of you that are really cool, can remember how to use the distributive property. Really, this is 5 times 3, which is 15, plus 5 times 1/2, which is 2.5, and so you get 17.5. So now, really, either one of these forms, they're the same thing. That would be your answer for find y when x is 5. So One thing I do want to talk about is the graph. This 3.5 is a positive slope. The 7/2 is a positive slope. If you remember, we've been talking about slope and how that represents a unit increase. We can use either one of these to graph. So we're going to graph now. And so those equations were y equals 7/2 x, y equals 3.5x, same thing. But let's look at the 7/2 x first. 7/2 is my slope. If you remember, the k value is the same thing as your slope. And so a direct variation equation always goes through the origin, or 0, 0. And now with 7/2, we're going to go up 7, 2, 4, 6, 7. Oops, I didn't mean to actually put a point there. There should not be a point there. That's not a point. Up 7, right 2. So my point is right there. I could also go down 7 and left 2 because slope is positive over positive, that's positive. Or I could go negative over negative. And a negative divided by negative is a positive. So I still have a positive slope by going down and left. So now I have these 3 points. I don't have a ruler with this device, but you should always use a ruler because you'll get much better graphs than what I'm about to draw. Okay, so there is our graph. If we had used our slope of 3.5, well, that's the same as going up 3.5, 1, 2, 3.5, and right 1. So because I didn't use a ruler, it didn't quite match up. But this 3.5 is really 3.5 over 1. So let's talk about the meaning of this. I could either go up 7 or right 2, or up 3.5 and right 1. This 3.5 is called the unit rate of change because it's over 1. So to understand what that might mean, if you remember yesterday we were talking about how with the miles and hours, this might be 7 miles in 2 hours, which is, guess what, 3.5 miles per 1 hour. Well, that would be very, very slow. That doesn't make as much sense. But to get a real-life situation that would make sense, suppose you and your friend go to the grocery store, and you pay $7 for 2 bags of chips, or pretzels, or crisps if you're in England. Now, if you have $7 for 2 bags, that means that each bag cost $3.50. So you can write this function that we've already written, y equals 3.5 times x, where if x represents the number of bags, y will represent the cost, and that cost is in dollars. So using this equation, we can find how much any number of bags would be. If you were having a party and you were buying 10 bags of chips, all you have to do is plug in 10. And so if you notice, here's the cost for 1 bag, would be $3.50, 2 bags, $7, 3 bags would be up here, it'd be $10.50, and so forth. So linear equations are very powerful. Please make sure you understand what slope means in context of the problem.